Hey guys, good morning all of you. So in this module we are going to discuss one more use of change in resistance, and we are going to study strain gauge. Again, very important concept. So let's begin. So just pause the video just to see the construction of a strain gauge, what exactly is happening here. Okay, so let's begin. Now what you see is there is something in the background of this metallic wire, right? So this is some metallic wire going zigzag here, and there are two terminals of this wire. And if you see the thickness of this, it's nothing, it's negligible. It's a 2D structure, it's like pasted, like a wire pasted on this yellow material or paper sort of an equipment like this, right? So it's something like this in reality. So two wires coming, then this material very thin, it's like pasted onto this backing material, and this is what a strain gauge is. So what is this? This is just a resistance. This is nothing but a resistance.
Hello ETO aspirants, Jai Hind, Jai Bharat, Jai Mata Di. If you want right information, right guidance, download Merchant Navy Start app right now. If you are looking for online recorded classes or online content from where you want to study, go for ETO Aspirant Excellence Package on Merchant Navy Decoded. What are you waiting for? Jai Hind, Jai Bharat, Jai Mata Di. The link is in the description box. Take care, bye.
Now why have we shaped it like this? Because we can paste this material on any surface, and if that surface bends, maybe because of load, maybe you're standing on it, so any kind of load, maybe it's like a weighing machine, or it could be some other kind of deformation happening to the surface. So if the surface is deforming, this wire also is deforming at the same time. And what exactly is happening when the wire is deforming? You know the formula now. Resistance is equal to rho L over A. So this is a resistance, equivalent circuit I have made. It's a resistance over here. Now this value of resistance I am measuring between these two terminals. What is the ohmic value, ohms value of this strain gauge? It will totally depend on the resistivity of the material, length and area. Let's not focus here, let's focus on these two terms. If I'm bending this over, if I'm bending this or deforming this, let's say this is my strain gauge. If I'm deforming this, you will see that its length slightly increase. If I'm bending this, of course the length will slightly increase. It will kind of stretched out. What happens to the area of cross section? If the length of any solid material is increasing, let's say any wire I'm increasing the length, then fractionally you will observe that area of cross section is going to drop, because the volume has to remain constant. So when my length increase, the area will slightly decrease. And what is happening here? Let's see what is happening here. So once again, rho L over A. So when there is a deformation, length is going to increase and area is going to decrease. So when length increase, resistance will increase, and when area decrease, again resistance increase. So it's a double action. So that means what is happening when I'm bending this by applying some force or pressure or some torque, anything, I'm putting some kind of load here, and this is bending, resistance is changing. And do you know how to measure a small change in resistance? Which equipment to be used? Yeah, that's right, you guessed it right, Wheatstone bridge. So we'll come back to the Wheatstone bridge again, right here. So things are interconnected. If you know the Wheatstone bridge, you know how can I change the resistance. You can measure the change in resistance, and at the same time you can also measure the property which changes the resistance. That could be a load, that could be torque, that could be weight, right? So that is why this principle is going to be used to measure those deformations. That means this principle can be used to measure load. Let's say your weighing machine, you're using a digital weighing machine, so this principle is going to be used. Where else you can measure torque here. Where do you need to measure torque on ship? Shaft torque meter. So your main engine shaft, so you want to measure the torque in the main engine shaft. And what is the formula of power? Power of shaft is nothing but torque times angular velocity. So if you know the RPM, you know the torque, you also know the shaft power. So that means if you using this thing, you can also measure the power, shaft power, right? So these are things that you can use this principle to. So again, if I'm bending this wire, my resistance is changing, and bridge is measuring any change in resistance in any arm. How? Because my voltage across these two terminals will change, which I can amplify and measure it. Simple, isn't it? All right. So I hope this part is clear. Uses of a resistance, the strain gauge is nothing but a resistance. I am changing it not by temperature this time, because I'm not reading temperature. I'm changing it by using some kind of mechanical deformation. So those mechanical deformation now I can measure how high the deformation was, and deformation are created by pressure or force or torque or load. All these parameters I'm going to measure using this principle here. So this is shaft power meter on a ship. This is the indicator which is telling me what is the shaft power at any given time, what is the torque value, what is the thrust value. Everything is being measured using a shaft power meter on board ship. And what does a shaft power meter use? Strain gauges. Let's see that. So this is main engine shaft. Transmission shaft. Your main engine is rotating the shaft, and the shaft is ultimately connected to the propeller of the ship. So there will be torque generated inside the shaft. I want to measure the torque. Why? Because I want to measure the power I'm transmitting to the propeller of the ship. So my main engine is giving torque to the propeller, which I want to measure, right? Okay, so this way I'm measuring my main engine output actually, what power my main engine is generating. So I'm using this equipment now, which is shaft power meter. And how is it measuring? Let's see. So you can see that in that case I'm not using one, but all four bridge of the Wheatstone bridge, all four arms, they'll be using strain gauges in this form. So this is an actual picture of a shaft onto which these four strain gauges are pasted. You can see that they are pasted, and whenever the shaft moves, there will be very, very small deformation in the shaft, which we cannot see through naked eyes, but this equipment is very sensitive. So even if there is a deformation at the scale of, let's say, 1 micron or 1 nanometer also, this can easily measure it. So when there is a twist in the shaft, of course there will be a twist. Why? Because my propeller has got inertia, it doesn't want to move, and propeller has got inertia, also it has got a drag, it has got a resistance. Water doesn't want propeller to move, so propeller doesn't want to move, but main engine is forcing it to move. So there will be some marginal twist in the shaft. So these twists is a small deformation. So I am measuring those deformation in the shaft. So if I take a shaft, let's say this is a shaft here, this side you have propeller, this is side you have main engine, this side you have propeller of the ship. So what happens, let's say a main engine is trying to turn it let's say this way, but this doesn't want to go, so it will resist the motion this side. So when this will create a torque or deformation like this. So let's say if main engine is not running, if I want to make some imaginary lines on the shaft, this is the imaginary line. However, if the main engine start turning and I'm imparting torque, so what is going to happen is these lines are down and these lines are up. So my lines will basically shift to this. Now I'm exaggerating this. Of course, this can't be this much huge deformation, but ultimately this is going to happen like this. Let's say you arm twist something, right? So if let's say somebody is arm twisting you, you can see the deformation in the skin. It's the same thing, right? So the same thing is happening in the shaft, and these deformation you are measuring using the Wheatstone. So there will be deformation in the Wheatstone also. These resistance element also. Same thing you are measuring here. Okay. So this is all about the strain gauge, gentlemen, right? So I hope the concept is understood. We'll see few more application. So till then, bye bye. Thank you so much. See you.